Hello, welcome back. Let's continue our discussion about finding volume using a double integral. So for the last example we're going to talk about is a figure bounded by a triangular base. For triangles, the way we solve it would be to sketch the triangle, and you can have a choice. You can split the region into two smaller triangles. So a lot of times we're going to have to split them into two smaller integrals for us. We would then find the functions that restrict the area in terms of either x or y. So let's take a look here. So they give us this equation right here. Well, this is a volume equation. Remember, this d right here is talking about the base. Sometimes we use r, sometimes they use d. The dA right here, that's, remember, our dy dx. So that's the area of our base. And our triangle has the following vertices. So what you definitely want to do is sketch it. You want to see what this looks like. Our first point is at 0, up 3. We have another point at 1, 1, and then at 5, 3. All right. So there we have our triangular base. Now remember, this base is being projected to that height. This is what we're going to project to our function. So once we get this, we're ready to find out our limits on our domain. So I'm going to do this two ways, okay? Because we're going to find out sometimes it's easier depending. In this case right here, I'm going to start off with a vertical rectangle. So if I start off with a vertical rectangle, I just go ahead and write down the word vertical. This is going to put everything in terms of x, so that's going to give me my change in y. So before I can solve this, though, I have to come up with my equations. Because, well, what is this bottom equation going to equal? Well, I can solve this pretty easily. That's just y equals mx plus b. This is saying y equals, what's that? 3 minus, this is at 1, 1, right? So down 2 over 1, so minus 2x. So the base of this triangle is going to go from 3 minus 2x all the way to this line right here, which is just y equals 3. But be careful. It's right here. Because if I move this triangle right and left, it's going to come across this boundary right here where everything changes. And this is telling me we have to split our integral. Because if I draw my new rectangle over here, my top is still 3, but my bottom is this new equation right here. And if I want to write the equation of this line, this is going to be y equals, this is, what's that, up 2 over 4. So that's going to be 2x minus, and if I just go down 2, down 1, 2, over 1, that's going to put me at minus 1 right there. Or what's that going to be? Oh, sorry. Down 2 over 1. So it's going to put us at 1/2 or plus a half, I guess. Sorry about that. Messed up on my slope there. Hold on. Which is probably what some of you guys kind of caught there. Messed up on my slope. That should have been 1 over 2 because it's up 2 over 4. Oops. Messed up on my slope there. I know you'll comment that in the comments below. I appreciate them. All right, so my other rectangle is going to have a change in y from 1/2 x plus a half all the way to this y equals 3 right there. Now they both have different x domains in their domain. So the first y, its change in x will be from 0 to 1. Over here, this rectangle, its x's are going to change from 1 to 5. And I can now, of course, write my volume equation right here. So my first one, my double integral, my function, 6x squared minus 40y. Now, be very careful. I'm choosing y first, so it's dy dx. And we're going to evaluate this one from 3 minus 2x to 3, and this goes from 0 to 1. Plus Now I'm going to do this one. My double integral, again, 6x squared minus 40y dy dx. Ready? This one goes from 1/2 x plus a half to 3, and then from 1 to 5. Now again, notice the inside domain has to match the outside variable there. And that's what we would get for this one. And of course, you would solve this one. Now, we are in luck. I'm going to do this one another way, okay? I'm going to do this one another way over here, all right? Because we're in luck. That's a horizontal line right there, so that's actually kind of nice for us. If I look at it this way, 1, 1 is a point. Here's 3, 0. And over at 5, 3. Instead of doing vertical rectangles, what if I did a horizontal rectangle? In this case, for a horizontal rectangle, we don't need to split. That can make it a little bit easier for us to solve. But because I'm doing horizontal, we have to find x's first. So here's my minimum x, and here's my maximum x. So, but be careful, we now have to solve these in terms of x. Well, this one's not so bad. If I just solve here, this was, remember, y equals 3 minus 2x. This is going to give us x equals, let's see here, I'm going to subtract the 3, so it'll be y minus 3 over negative 2. So there's my x. So there's my minimum x. So y minus 3 all over 2, negative 2. All the way to over here to get my max x. Well, this was 1/2 x plus 1/2. If I multiply everything by 2, that's going to give us x equals 2y, and that becomes minus 1. So we get this 2y minus 1. Now the change in y's here, again, I don't have to worry about splitting it like here. My change in y's are going to go up and down here. We go from 1 to 3. And I can write my integral, my double integral, my function still, my area, my volume, my height, which is a 6x squared minus 40y. But this time dx dy, because remember we're doing x first with the horizontal. And this, of course, would become, if you want to simplify that, what's that? 3/2 minus 1/2 y to 2y minus 1, and then from 1 to 3. And if you have to solve by hand, I think that one might be a little bit easier than this one, at least time-wise. All right, so I hope you guys enjoyed the video. If you want to see the answer for this one, I worked out the original here, and you can take a picture of this real quickly. Are you ready? I worked out the original here. Here it is. And you can take a look at that when I did my split there, okay? You can look at that answer, and you can, can't even see it all. That's how big it is. There it is. All right, so you can take a picture of that if you want to take a look at that and solve it. Good practice for you for calculus. All right, hope you guys enjoyed this video. I will see you all later. Bye-bye.